This is the extra credit videos on help with your curve sketch analysis. So it's just right in your note packet. You can go ahead. I think I'm going to be doing examples 1, 2, 4, and 8. So open up your note packets and just go through it with me. And when you're done, just make sure I see it. So again, remember your biggest task or biggest helpful thing is to make sure you label the graph really big with what you're looking at. This is a graph of all the slopes of f. I can't see f, but I know right here because y is positive and y is f prime that the slope on the graph of y, if this was 4, the slope was 4, which means y was going uphill quite steeply. All right, so let's begin here. For bullet number 1, for what values of x does f have a horizontal tangent line? That would mean if its tangent line is horizontal and the derivative is the slope of the tangent line, it'd be where f prime has to equal 0. This is the graph of f prime, so I'll be looking right here where all these y values or f primes are 0. So we would say at x equals -5, -3, 1, and 4. And if I wrote a sentence, I would say this is where f prime equals 0. I'm not going to write the full sentences out. Now, those are also all called critical values. Some of those are relative extrema, and your task for the second bullet is to figure out which one has a relative max. Remember, for a function to have a relative maximum, it must be going up and then down, or down and then up, which means its slopes, or f prime, must be positive and then negative, or negative and then positive. So we look at where f prime changes sign. In particular, for a maximum, we need f prime, the slopes, to go from positive to negative. So I need f prime to go from positive to negative. Well, these are the graphs of f prime. So I need y to go from positive to negative. That occurs at this critical value, and over here, I think that's the only one where we go from positive to negative. So we would say at x equals -5. For what values of x does f have a relative minimum? Same thought process. We need y equaling f prime to go from negative to positive. So I look at where the y's go from negative to positive. They're negative over here. They're still negative. They hit 0. That means actually f had a plateau at -3, is going downhill for a long time. Then it continued to go downhill. So we would be at 1. Is where there would be a relative minimum. And if I wrote my answer in a full sentence, I'd say since this is where f prime changes, and you'd have to be specific, you can't say changes signs, otherwise we don't know if you have a min or a max. So from negative to positive. On what intervals is f increasing? If a function's increasing, then its slopes are positive. So we need f prime to be greater than 0. But our y values are f prime, so we need our y's to be greater than 0. So we're just looking above that x-axis for that one. So we're going to be -infinity to -5. Sorry, my thing got off. -infinity to -5, union 1 to, let's say, infinity. Now what happens from here? You know, it becomes 0 and then goes. You can sometimes do 1, 4, union 4 to infinity, or some people would say 1 all the way to infinity. I tend to gravitate towards this one, but the argument against it is that you can only increase or decrease on an interval. You can't increase or decrease at a specific point, so you're actually increasing through the point 4, even though for a split second there's a horizontal tangent line. So either one is acceptable. I actually think this guy is preferred on the AP exam, but they accept both. What intervals is f decreasing? Similarly, that'd be anywhere where f prime, which is my y's, less than 0. So I'm looking below the x-axis, and you can go ahead and write that down. Where does f have an inflection point? Well, now my graph's getting a little messy, so I'm going to scoot it down here. A function has an inflection point anywhere where the second derivative changes sign. So I need f double prime to change sign. Just going to put that down as a little note to myself. But I'm not looking at f double prime. So because this is the graph of f prime, I need to decide in my head what does f prime have to do. Well, to go from f prime to f double, I need to take a derivative or think of slopes. So I need to make sure that f double prime, or the slopes on f prime, change signs. So what I need to make sure is that this graph goes from decreasing to increasing or vice versa, because right here on f prime, this slope is f double, it's negative. Slope here, f double, it's negative. Slope here, f double prime, it's negative. Right here, the slope, or f double prime, is 0, and then we go positive. So for this question, we're really looking for f prime to change from increasing to decreasing or vice versa. That happens here, and here, and here, and here, and here. And that bodes the question, is it at the extrema of f prime? And the answer is yes. So you would list all those points. On what intervals is f concave up? We need f double prime to be positive, but I'm looking at f prime. So I need to make sure that my slopes of f prime are positive. F double is, that red thing means take the slopes of this. So what I need to do is make sure my slopes of f prime are positive, which means I need f prime to increase. So you'd give all the intervals on that graph where it's going uphill. Similarly for this one, I'd need f prime to decrease. If a function is decreasing, its derivative is negative. So that will give me those concave down intervals. The next one I'd like to look at is number 2 on, there's a couple different ones here. I want to go to this guy, the first 2. First of all, what am I looking at? It's the following questions about g and g prime on the interval. I got to see what this is the graph, this is the second derivative. So I'm going to write y is equaling g double prime on this one. Where's the graph concave down? We know that we need g double prime to be less than 0. You would have made a study guide for the last chapter where you said concave down is about the second derivative being negative. But this is the graph of the second derivative, so I really need y to be negative. I look below the x-axis, so that would be from 2 to infinity. How about where does g have an inflection point? Again, that's about g double prime changing signs. Should have put that on your last study guide, and you would have done an example where you would actually took the second derivative and you'd have found where it was 0 or does not exist, and you would have decided the second derivative, and the inflection point occurs where the second derivative changes signs. So I need my y values to change signs. Y is positive, 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 which means g double was positive, which means g was concave up. So right here at 2 is where we had a sign change in g double prime. We won't do part C, we'll do that one in class at some point. The next one up is number 4. All right, so number 4, we've got the graph of the derivative. So we're back to now looking at the first derivative. I'm trying to float between them. So this is a graph of f prime, also known as the slopes of f. Where are there critical numbers of f? That would mean that f prime equals 0 or does not exist. So this is the graph of f prime. I need y to equal 0 or not exist. That's here, here, and here. Be careful that you don't think that it's here, because f prime at 0 is -2. It's f double prime that would not exist at 0, so be careful with that. So our answer to that one would be -1, 1, and 3. So let's say at x equal -1, 1, 3, done. On what intervals is f decreasing? For a function to be decreasing, its derivative has to be negative. I'm looking at the derivative. My y's have to be negative. I'm below the x-axis, so I'm from -1 to 1. Have a good weekend. All right, and last up it says, at what x-coordinate does f have a relative max? Again, that's about f prime. It would have been last chapter if I made a sine line and it went plus, minus, plus, and I was looking for the relative max, I'd say right there. So that's the same thing I need to do on my graph. I need to have f prime change from positive to negative. but that's my y values. So I need my y values to change from positive to negative. Where does that happen? Right here. That's it. So we would have at x equals -1. And lastly, for this one, on what intervals is f concave down? Again, let's go back to the last chapter's study guide. If you wrote about concavity, you'd say that occurs when f double prime is less than 0. But I'm looking at f prime, so I need its slopes to be less than 0. For a function's slopes to be less than 0, it must be going downhill. So I need f prime to go downhill or to decrease, because then its slopes would be negative. All right, so let's go look at where my y equals f prime is decreasing. Back up to the graph. My y's are decreasing from here, 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 here. Again, this is f prime. The slopes here are f double prime. Slope is negative, slope is negative, slope is negative. So f double prime is less than 0 over here, meaning f is concave down, and also over here. So we'd say -3 to 0, union 2 to 3. -3 to 0, union 2 to 3. All right, and last one, number 8 for the extra credit notes. It'll be at the bottom of this last page for us. All right, let's see if we can get that graph in there a little bit better. Come on, graph. There we go. Ah, crap. All right, whatever. I'm trying to get the graph on here nicely. There we go. So suppose that f of 1 is 5. That's a point on f. Whatever f looks like at 1, 5. There's a dot. I don't know what f looks like. It says find an equation to the tangent line of the graph there. Maybe it looks like this, and I'm trying to get this tangent line. Well, the equation for a line is y2 minus y1 is equal to the slope times x2 minus x1. I need to get the slope at that point. The slope is the derivative, so I need to figure out f prime at this point. So I go back to my graph and I say, this is the graph of f. What is f prime at 1? And that's why I left this one for extra, because I didn't label these. Let's suppose that's up at 1. Then I'd put a 1 there. And so I could leave that. No need to put it into slope-intercept form. Same here. I've got a point on a graph. So a line through it will have y minus a -6 is equal to the slope times x minus a -3. I need to get the slope there. And this is the graph of the slopes there. So it would be 0. This right here would be f prime of -3. It's the point -3, 0, where my y's are f prime of x. Just so you have that down. So I'd put a 0 here. Really what that means is there's a horizontal tangent line, so it's really just y equals -6, but you can leave it. So if you took these, you can go ahead and make sure I see them. If you're still not quite comfortable with the curve sketch, come on in and we'll get it all straightened out. Have a good one.